Hello everyone, welcome to MES e-learning channel. In this video, we will be looking at a sum on Unity Feedback System. So here in the question you can see they have given us the G of s, H of s equation. Along with that they have asked us to find the value of k to limit the steady state error to 10, meaning they have given us the value of ESS, that is the steady state error, as 10 when input of the system is this. Okay. So, the input meaning R of t is 1 plus 10t plus 40 by 2 into t square. So, we can also write this as like this 40 into t square by 2, right. So, this term indicates step input, this indicates ramp input, and this indicates parabolic input, correct. So, the term which is just a digit will indicate step input, term with t will indicate ramp input, and term with t square by 2 will indicate parabolic input. Okay, just keep that in mind for easy understanding. So, now the first thing is they have asked us to find the value of k. Now, let us try to do that. So, for that we will have to find out all the error coefficients, correct. So, we will have to find all the error coefficients. What all are the error coefficients? We have Kp, Kv and Ka. We will have to find out all these three values, correct. So, we can find Kp, right, using for step input, we can find Kv using the ramp input, and we can find Ka for the parabolic input, correct. So, let us start with step input. Now, what is the magnitude of the step input? It is 1, correct. So, the magnitude, okay, which can be indicated by A or say A1 is 1, correct. So, what is the formula for Kp? We know it. So, we will write down the formula. Okay. So, G of s, H of s, the transfer function is known to us, it is given to us in the question. So, we will substitute the value over here. After substituting the value of G of s, H of s, what we will do? We will substitute the value of s as 0 in this particular equation. After doing that, what will happen? We will have a 0 term in denominator. Why? Because we will multiply 0 with the entire term, ultimately k by 0, and k by 0, anything, as I told you in the previous lecture, k by 0, anything by 0 is going to give us infinity. So, Kp is equal to infinity. Now, we will find the error coefficient, right. So, the steady state error in this case, that is in the case of step input, is the formula is A, that is magnitude upon 1 plus Kp, correct. So, we know the magnitude, that is 1, we know the value of Kp is infinity, right. Like I told you in the previous lecture, anything divided by infinity will give us 0. Here we have 1 plus infinity, but ultimately 1 plus infinity is also infinity. So, the answer is ESS1, or the steady state error in case of step input, is equal to 0. Let us move ahead and do it for ramp input. So, for ramp input, right. So, for ramp input, let us see what is the magnitude. We can see that the magnitude here is 10, correct. So, magnitude in case of ramp input is, let us say A2 is 10, correct. So, let us find kV. Okay. So, the velocity error coefficient is responsible in case of ramp input. So, we have the formula, let us write it down. Let us substitute this value. Okay. So, here this s and this s square will get cancelled out. Okay. So, we will have this term again. When you substitute s as 0 in this equation, we will have 0 in the denominator, hence the value is going to be infinity. So, kV is equal to infinity, right. Now, let us calculate the steady state error. Okay. So, the formula is A upon kV. A is the magnitude, we know it, it is 10. kV is infinity. So, 10 upon infinity will give us 0 as answer. So, ESS, that is the steady state error in case of ramp input is 0. Now, let us move ahead for parabolic input. So, what is the magnitude? What is the magnitude in case of parabolic input? You can see here the magnitude is 40, correct. So, let us write it down. Okay. So, the error coefficient Ka is, we know the formula for this, let us substitute the value of g of s, h of s in this equation. Okay. So, after substituting, this s square and this s square will get cancelled out. After that, we will be substituting the value of s as 0 in this equation. So, we will have k upon 0 plus 2 is 2 into 0 plus 3 is 3. So, we have k by 6. So, the value of Ka is k by 6. And now, we will be calculating the steady state error. In this case, the formula is magnitude A upon Ka. Okay. So, A3 is 40, which is known to us. So, 40 upon K by 6 will give us what? 40 into 6 upon K, which is 240 by K. So, the value of ESS in this case, that is ESS 3, is 240 by K. Now, let us calculate the total steady state error. Okay. It is equal to what? Steady state error is ESS, and it is the sum of all the steady state errors from all the inputs, that is step, ramp and parabolic input. So, we have the values of all of these terms. So, ESS 1 is 0, ESS 2 is 0 and ESS 3 is 240 by K. So, 0 plus 0 plus 240 by K. We also know the value of ESS, it was given to us in the question itself. it was 10, right. So, let us substitute the value as 10. Okay. So, we have to find the value of this k, correct. So, how do we do it? After calculating, you will get k is equal to what? 240 by 10, which will give you answer as 24. So, the value of k is 24. I hope you have understood. If you have any doubt, please put it down in the comment section. Thanks for watching.